Okay, so this video is going to be a little bit different. This is actually a tool review I'm doing for the manufacturer of the tool. I was contacted by Daryl over at DT Tool Holders. They're based out of Florida. And he said he has a tool that his company makes for lathes that he wanted me to try out. Now his company also makes these tools that I'm going to show you. They also make retrofit kits for screw machines and also brake lathes to take standard inserting tooling. And you'll see his company logo, company name up here, and you'll also see in the comments his website. So he sent me these tool holders that he makes. And this one here, this is made out of steel, and this one here is a twin made out of aluminum. And we're going to test both of these. Now just for contrast, you know I use A.R. Warner tooling, and those are my two A.R. Warner tool holders as compared to these. Now they are the same thickness. These are 1/2 inch by 5/8. The extra width is obviously to take the larger insert. And I believe these go up to 3/4. You can get these up to 3/4 of an inch square. So now the main difference between these is the A.R. Warner stuff is a positive rate tool holder, meaning that this insert is held up in at an angle in the positive direction, whereas these are negative rate insert holders. So these take CCMT 3251s, and these take CNGP 432s. So you can see here that this insert here is held up at an angle like so, whereas this in relation to the part is held at a negative angle. Okay, so that effectively gives us 4 more corners to use on these tools. On these tools, because of the positive insert, you'll only be able to cut on this edge and then flip the tool around. On this, you can actually flip the tool completely upside down and get 2 other usable edges. In other words, the insert is the same. The insert is the same on all sides, whereas the CCMT stuff is only single-sided. Okay? And there you go, you can see the actual physical size difference of the carbide insert. Now, for us with smaller lathes, you really can't get CNGP or CNMG even, any kind of this configuration of insert in a 1/2 inch shank. Usually you can only get the triangle ones. Or if you can, you would get a holder like this, which this is a CNMG insert. You would get a holder like this and cut it down to fit your lathe. Now just to show you the difference between a CNGP and a CNMG and what the difference is, let's take a closer look at these two inserts, and I'll show you what the difference is and why these ones here that this tool holder uses benefit our lathe, our smaller lathes. Okay, so these are the two inserts, and on this side here we have the CNGP insert, and this is a CNMG insert. Now the main difference between these is CNMG, I'm sorry. The M stands for a molded insert, and the P stands for standard chip breaker, whereas the G and the P on the CNGP stands for a ground insert and a positive chip breaker. Well, what's the difference? Well, if you feel the edge of this insert over here, the CNGP is much sharper because it has a ground edge. Also, if you look at the chip breaker, you can see that the chip breaker on the CNGP has much more of a positive geometry to it than the CNMG, which is what our lathes, the smaller lathes, like. You know, they're held kind of like in that configuration into the work, and you can see that this is almost becomes a regular positive insert, whereas this one, especially on small lathes, will tend to grab and kind of get pulled into the work. Now, just for comparison, here's the CCMT that the A.R. Warners take, and you can see the difference, and also that, as I said before, both sides are exactly the same on these, whereas these are single-sided. So you get 8 cutting edges per side, whereas per insert, whereas on this you only get 4. Now, you're going to say, well, you're getting a ton more carbide in these, so they're going to cost a hell of a lot more than the CCMTs. Well, not necessarily. Especially in the used market, where you can buy on eBay, where you can buy overstock. The price difference between these two inserts here really isn't noticeable, and you get a ton more carbide for your money off of these than you do these. And actually, the CNGPs are a little easier to find than the CCMTs, because the CNGPs here are more often used in industrial applications. So there are actually a lot more choices online for these on places like eBay than there are for these. So now for one of the more interesting aspects of this tool holder here. And what we have is, as you can see, it's double-ended. Well, how does that help us out? Well, what you'll be able to do is you're going to be able to zoom out. You're going to be able to turn. Okay, now picture this in your tool holder like this. So you're going to be able to turn, right? And then you're going to be able to take your tool holder out, flip it directly to the other side, lock it down, and then you're going to be able to chamfer inside and out. So you chamfer the outside and then lift it up a hair, and then be able to chamfer an inside bore. Now, if you take this tool holder, if it's required that you have a 45-degree chamfer, you can measure your tool post and kick it 45 degrees off of center. You kick it 5 degrees off of center, and then you'll have a 45-degree angle with which to be able to chamfer the outside of a part with, and that'll give you 45. So you can do 2 operations and only tie up 1 tool holder. So you'll be able to face, turn, chamfer, and you can actually face with this side of the tool also. And they're very well made. I'm not sure if Darryl makes each one of these himself, or if he subs it out to a local shop, but they are all made in the US, and the pockets are nicely formed and nicely machined. The only thing that is holding these in is the screw in and the pocket, just like the AR Warner things. So it's they're not like an insert type like this that takes the cam and the lock pin and the locking bar, but it's just basically the screw and the machine pocket that's holding this in place. But they're in there super tight and snug. I mean, there's no movement in these things whatsoever. So now he's, as I said before, he sent me the steel version, and we'll go through the prices at the end. He sent me the steel version and the aluminum version, and these are Sandvik CNGP 432 1005s in this here, and these are CNGP 4305 TN10Us in these. These have a smaller radius on the end in a different chip break configuration, as you can see. Those are in the aluminum holder. And he also sent me this, which is a Maxpro CNGP 43007 MP3, and these are specifically designed to cut aluminum, and only in aluminum. Your softer metals, they're designed to be able to cut the aluminum and break the chip. So what I want to do is we'll go through a test on a variety of metals in my lathe with both of these tools, and we'll also compare our finish on the part between the steel and the aluminum, and we're going to also measure tool deflection. So I'm going to take a really deep cut in the same material on both, and I'll have a dial indicator up here, and we'll see if this aluminum flexes any. Now, for an apples to apples kind of comparison, we're going to try to keep everything the same. So we're going to be running the same material, we're going to be running the same diameter, same depths of cut, which I'll write down as I'm doing it, and we're also going to do the same insert. So I'll probably take this insert off of here, and I'll put it on these, on the aluminum one, so we have kind of an apples to comparison. Just to show you a bit of the versatility of this tool here, So we can do, so you can come in and we can face. And this is stainless steel, so we faced. Go ahead and turn our part. And when we're done, we can zoom you out just a hair. Take your piece off, or your tool holder off, put it on our other slide. We can come in and chamfer and go in, lift up a little on our tool holder, lock it down, and go inside a large bore and chamfer that inside edge. You can do that all with this one tool. This is a very nice feature of this. So what we'll do now is we're gonna set up, and this is stainless steel and they made a perfect finish on that. And so what we'll do is we'll set up and we'll turn some, we'll start with something soft. We'll start with brass and see what the two aluminum and the steel tool holder do. And then what we'll do is we'll put a piece of steel in here and we'll actually measure the deflection of the steel tool versus the aluminum tool. Okay, so for every test we're going to be doing the steel tool first, and then when we do, I'll cut the steel, we'll take a really deep cut, and then we'll measure deflection between the steel and the aluminum tool. Everything will be done at the same speed, just to make it consistent in the same feed rate. So we're feeding at 5 thousandths per revolution, and our RPM is going to be on this lathe center pulley, so that's pretty close to 400 RPM. And I'm going to try to keep as much the same. So I'm going to turn a piece of this down. I'll probably turn this halfway down, and then I'll leave the other half for the other tool. And we're going to start off at 100 thousandths depth and work our way down, or work our way up. Obviously, as the diameter decreases, the surface feet per minute is going to decrease too. So, unfortunately, that's something we're going to have to deal with. But this will be a pretty good test to test all this out. Now, this is just brass, so I'm not expecting any issues from this. So we'll see how this works. I'm on you. Now this is just brass, so I'm not expecting any issues from this. So there's our touch. I'm going to go in 100 thousandths. So that's taking that without an issue. Got a pretty good finish on there, actually a really good finish on there. Now, if we wanted to chamfer the part, all we have to do is take this out, put it to the other side, and there's our chamfer. All without tying up other tool holders. So right now, I can go back here and just reset my 0. So that was 100 thousandths. Let's do 200 thousandths. Alright, so that's not an issue. So there's 1, 2, and there's 300 thousandths. Alright, so I mean that did perfectly fine. I had no issue doing that whatsoever. So let me get the aluminum tool in here, set up in another holder, and we'll see if that can do the same thing. Okay, so now we have the aluminum holder in there. We have the same insert that we have on the metal one, on the steel one, so we're gonna do the same thing. And we also have the same amount of stick out of the tool. So there's our touch. I'm going to do 100 thousandths depth of cut, so it's 50 thousandths per side. Same thing on the finish as it was last time. So there's 200 thousandths depth of cut. Again, no issues with it. Roughly the same finish that we had on the steel one. Now this will be a really good measurement of finish between this and this. We're going to take a 300 thousandths cut, so 150 thousandths per side. So there's 1, 2, and 3. And can't really tell much of a difference in that finish there. I'm trying to get a little, maybe a little sharper. They look almost the same. Looks like there might be a slight bit more of vibration in here in the aluminum one, but I'll be honest with you, it's extremely hard to to tell the difference. The only difference that I see in it, they look pretty much the same. Now, even if I were to come in just for, say, a 5 thousandths finish pass, I'm not even taking the nose radius on the tool, so. That's perfectly fine. Even any little bit of vibration that might have come from this being an aluminum tool could be taken out with a finish pass. Okay, so this is 1045. I'm going to be using the steel tool. I'm just going to slow the lathe down because I know I won't tolerate that speed on this material. But we're going to be using the same speed and feed for this and also the aluminum. So I'm going to take 100 thousandths. There's 100. That wasn't necessarily like that much of a feed rate. Just slowing the feed rate down a little bit. bad finish either. I don't know if you could tell, this here is a ground finish, and that's what it just turned. Okay, I have the steel tool set up, and you can see we're definitely touching. Same 100 thousandths cut. And you got about 100 thousandths difference there too. Okay, so setting 0 there, and you can see and we're definitely touching. And I'm going to run that same everything. I'm going to see if there's any deflection in that tool. One thousandth deflection in the tool. Okay, so this is the Maxpro Insert here, and we're going to try it on this aluminum, see how it does. And first things first is 100 thousandths cut and see if it breaks the chip. It might not. No, it's actually breaking the chip. That's not bad. Finish ain't too bad. Let me see. Let me try a little bit deeper cut. It's breaking the chip. I mean, you don't get that rat's nest. And as far as finish goes, we're just going to take a light cut. Let's say 20 thousandths or so. Not that bad of a finish. Let's try speeding up my machine here. Slowing down the feed rate a little bit. That's not too bad. I mean, I like that it breaks the chip. We usually end up with that rat's nest. So it's really good for at least for from this, looking at this, it looks really good on roughing the aluminum, not necessarily finishing it. Let me see if maybe if I put let me put this other insert in and see exactly what happens if I take the same depth of cut with a regular insert. See if we get those stringy, crazy chips everywhere. I'm going to do 100 thousandths here. See, we're starting to get the tangles. Yeah, see? Now you get the rat's nest going there. You get that rat's nest going there. As far as finish goes, let me see what the finish. Oh. So yeah, as far as finish goes, very light pass with the regular insert gives me a better finish. But this insert definitely breaks the chip, and I don't get that rat's nest going. So it'd be be pretty good idea to rough with this. Even I can feel. I think part of it is this comes to a very, very sharp point. I don't even know what the nose radius on these are, but it's pretty pointy as compared to this. But as you saw, this broke the chip, and you know, the regular insert turned into the rat's nest. So it'd be good to have, if you do a lot of aluminum turning, to have something set up with this insert for roughing and then a regular insert for finishing. But this definitely works. Okay, so our holder's held up really well. No problems with the aluminum one here. I mean, you got your couple of little, you know, divots from the screws, but other than that, we're fine. There's no line or anything on the bottom. Nothing that I would consider really bad. The only thing I would ever worry about with the aluminum one would be stripping out the screw holes. But again, I don't think you're going to do that. This is 6061 aluminum. I don't think you're going to do that unless you really gronk on these screws. And the only other thing I would ever worry about with this is crashing it. It's that if you rub this into the chuck for any reason, which, I mean, let's be honest, people have, it does happen. You're going to chew this up a little bit more than you would the steel. But, you know, everything worked perfectly fine. And the aluminum one, what I noticed too is the aluminum one held up perfectly fine. There's nothing wrong with the edge, and also all the chips came right off of the insert, whereas the carbide one, you kind of get that chip that welds to the tip and kind of screws you all up. But the aluminum insert, I mean, they slid right off there like this was Teflon. So now, as far as pricing goes, we have this steel tool holder here, a blank tool holder without any inserts, is going to run you $140. The blank aluminum insert without any inserts is going to run you $80. So there's your price difference. Now the holder with 2 inserts and the aluminum insert, which is what he sent me for the steel one, is going to run you $200. And the aluminum one is going to run you $140. Now the holder with 8 inserts, 8 steel inserts and 2 inserts, 2 aluminum inserts, in steel is going to run you $265, and in aluminum is going to run you $205. Now he also has 5/8 and 3/4 inch shank tooling, and for the 5/8 you add $25 to those prices, and for the 3/4 you would add $50 to those prices. Okay, one little thing I wanted to just point out. These are the inserts that I used on camera, which are CNGP 432s. They have a 31 thousandths radius to them. These ones here are the CNGP 430.5, I believe what they were. And these have a 8 thousandths radius on the tip. Now, off camera, I put these in and did the same thing. My lathe liked the smaller radius way better than I liked the larger radius. Mainly because there is less tool pressure on these, and I have a lighter lathe. So these worked fine. The finish came out fine. It was perfectly acceptable. If you wanted a better finish, you can do the finishing cut with a larger radius. But these smaller radius tools here, they worked much better on the smaller lathe. Now I did some just price comparing here, and these are the CCMTs that the AR Warner stuff here that I have uses. And as I said before, you have 4 usable sides, 1, 2, 3, 4, nothing on the bottom. Whereas on these inserts you have 8, 4 on the top and 4 on the bottom. So I did some price comparison here, and went on Enco and chose the Seco brand because I believe that's their cheapest name brand that they sell. And we have for the CCMTs, now this is price per insert. These are $12 to $15 an insert, and these ones here are $15 to $20 an insert. Now I also went onto eBay to look at that, and eBay is a really good place for inserts, especially for the home shop guy. You can get overstocked inserts. This is where I got a lot of the inserts for my AR Warner stuff. And the funny thing about that is for CCMTs here, you're looking at, for a pack of 10, $5 to $9. And for a pack of 10 of these, you're looking at $3 to $10. So there's roughly the same price, and sometimes a little bit cheaper on these guys. And if you look at how many pages they have of the inserts, there were a lot more of these available than there were these. So as far as the tooling goes, you know, really good stuff, I have to say. It works really well, and it worked perfectly fine on a smaller, relatively underpowered lathe. You know, I only got a 1/4 horse motor on there, and it ran perfectly fine. And the smaller radius stuff worked even better. So these will definitely, you know, be one of my go-to tools that'll keep in a holder and use almost all the time. The AR Warner stuff, you know, I'll use that also. It's kind of a combined arsenal. Sometimes the positive radius on these will help you out in certain cases, but as a general all-around tool, these work great. And even if you have a larger lathe, you can use these and probably get better performance out of these than I can on my lathe. So I mean, it's definitely an option if you guys are out there looking for tooling, looking for something different. And this is technically, you know, two tools in one. You got one tool there and one tool there. You can tie up only one tool holder, especially for you guys using very expensive tool holders or harder to find tool posts like the Multifix or something like that. You only have to tie up one tool holder. You'll be able to face and turn and chamfer all in the same, all off the same holder. Even with the AR Warner stuff, you can see we have a right-hand tool holder and the chamfer is on the left-hand tool holder. So, you know, I have to tie up two tool holders to be able to turn and chamfer. I'm overall, you know, I'm real happy with the way it worked. And if you guys want any of these or want any more information, go to Daryl's website, DT Tool Holders. You can see it down at the bottom of the screen and down below again. And that's it. I hope you now. I believe he has some of these in stock. He may have to make more depending on the orders. I'm not exactly sure what he has in stock and how many. You'll have to go through that with him. But if you want one, check out his website. And hope you guys like this video. And we'll see you on the other.